Okay, welcome back. So we're still on page 168 and we're going to section 8.2, which is studying the angles of a triangle. Okay, so and as you can see here, we can name the angles of a triangle A, B and C. And just a subtle little point is that when we talk about this angle A, and we look at this, the size of angle A, or the measure of angle A, plus the measure of angle B plus the measure of angle C, and you say it's 180 degrees, you can certainly agree with me, I hope, that this is quite cumbersome. So we're only doing school maths here, so we don't want to be too rigorous in our language and in our notation. So we'll be absolutely fine with just saying A plus B plus C equals 180 degrees. And so we will be interchange the whole idea that A is this special thing called an angle, and the measure of it are the same thing. Okay, so we can simplify what it says there to A plus B plus C is 180 degrees. Now, one thing I would have liked them to say there is that in a triangle you have interior. So we'll start with our work. Let's draw a working line and let's do this ourselves. Let's not just look at a book. Okay, so let's come up at any particular angle there and come back down at any particular angle. But don't come down to the end of the line of our working line segment. Come down to somewhere along it. Okay, so now we're going to mark A, and I'm going to just say these are internal angles. Internal angle A, it's inside the triangle. Internal angle B, internal angle C. And I want you to, and then we're going to mark this one D, and this is called the external angle. Okay. Now, I just want you to realize that we're not talking, when I talk about an external angle here is not the reflex angle all the way around there. You do need to create the extension here to talk about the external angle, and there'll be more about that as we go on. Actually, it's right here. I said external, they say exterior. Okay, I stand corrected. Surprise, surprise. Exterior angle. And in that case we would call them not internal but interior angles. Okay, so the sum of the interior angles adds up to 180, and this interior angle they're going to say here is equal to C is equal to the, and this is a theorem in your course, it's a big deal. We're talking about it now, so I'm going to prove it to you. But we'll be doing this in another chapter as well. Okay, so basically you will agree that these two add to 180, right? So I'm going to keep this as hand wavy and just to convince you. So I can write down that C plus D equals 180. Okay, but I can also write down that A plus B plus C equals 180 degrees. Okay, and so we can see that D could be replaced, or is the exact same as A and B. So A plus B equals D. Okay, you either see it or you don't. One way or the other, what you want to know is that the external angle is equal to the sum of the two internal angles. Okay? And we'll be using that in this theorem. So some more language here, and we will be active learners. So we're going to, I'm an active learner, you're an active learner. So please tell me you have your compass with you now and you have paper. Okay, because we're doing geometry, you'll see, and generally I prefer plain paper because I write very big and I find it hard to keep between the lines. But it's okay for you to be using line paper, but just remember, don't use the lines on it. And it would be better actually if you were using plain paper. Whenever you're doing a geometry question in your exam, you'll see that the box is completely empty, it's plain paper. Okay, and the reason for that is no x-axis or y-axis, there's no direction when we're doing geometry. Okay, so what we're going to do here is we're going to start with a working line. Okay, keep it short, open up your compass, that amount. Okay, and draw an arc up nice and generous above 90, up more than a right angle, and do the same here until the arcs intersect. So once they intersect here, you're done. Okay, so now congratulations if you've done that and you're not just looking at me. Take out your compass and do it yourself, and then you've created the 3 points that form an equilateral triangle. Okay, and we know this because as I dragged up this, I was using my compass as a constant measure, okay, a constant arc length, and so that these are all the same. And because they're all the same, I could put letters on them, but I could also just mark them like we do in geometry to say they're equal. Okay, and if the line segments are equal, the angles are equal. So I can mark these to be equal. I can give it a name, A, and A, and form the equation 3A equals 180 degrees, and divide down the A, and we get 60 degrees. Okay, now let's form an isosceles triangle. Again, I'm going to keep saying it to you. Start with a working line. Please do this. Okay, the thing is, you just open your compass a bit more generously, or a bit less, it doesn't really matter. Make sure, oh sorry, I came off screen there. Make sure you're at least, make sure you're not exactly the same length as your working line. So shorter or longer. I'll go longer, but I'm being very generous here with the amount of paper I'm using. Okay, so I'm going to go longer, but you can go shorter or longer. Just don't go less than half of the line segment, because if you do, you're not going to be able to complete your triangle at all. Okay, so that gives me a nice tall isosceles triangle. We mark our endpoints and we mark our intersection point of the arcs there. Congruent arcs, both arcs the same length. And now we have an isosceles triangle, and we have a base. We have base angles. Let's call them B and B for base. We have a vertex angle. Let's call it V for vertex angle. Okay, and we have, of course, the word SOS, SOS, sending out an SOS. Maybe you know that song, maybe you don't. ISOS, ELE, SELE. Okay, so you have a palindrome and a palindrome, and you have a C, isosceles, isosceles, isosceles triangle. Okay, let's spell it again. Isos. There's a C in the middle. There's an L. Isosceles. Make sure you can spell it. It has 2 base angles. It has 2 congruent sides, and it has a base. So the base is the odd one out, but the base angles are not the odd one out. The vertex angle is the odd one out. Brilliant! You know loads about isosceles triangles now. Okay, a right angle triangle. So let's make ourselves a right angle triangle. Let's keep it simple. Let's not go with a 45 degree, because if we do that, then two of the sides of the triangle are going to be the same. So let's take your 30, 60, 90, put it out there, hold it down nice and steady, and join it in. Okay? Now, as you know, I'm a big fan of Mr. Price, and this is the geometry set I'm using. It is €1.99 in Mr. Price. Okay, you don't have to use this one, but I like lots about it. I like the fact that some of them have rounded corners on the insets in the set squares, and that's not much good. Okay, because our corners should be nice and sharp. Our vertices, our vertexes, our corners. Okay, so you draw your corner. We'll call it, now, don't like the way they call that A there, because it's in Pythagoras it's C. So we're going to call this C, call this A, and call this B, and we'll just refer to the trigonometry section, which is it back the way or forward away compared to where I am in geometry. Let's see, it's just behind me in geometry. So going back one page, actually, we get back to this. So And now the next time I make a video like this, what I'm going to do, and you might say that's too much planning, but what I'm going to turn this set square the way it is here. Okay, because this is a right angle triangle, and this is the only right angle triangle you can look up under the pressure of your exam, page 16. So we're going to go like this, and why change the letters around when this is a lovely reference for you? So we'll go with C, A and B, but you can say, I hope you can appreciate why I'm changing slightly from your book, because this is the real book. This is the one you can bring into the exam with you. You can say it's an open book exam because you're allowed to bring in this booklet. Okay, so it's a right, we know what a right angle is. It's 90, an angle of measure 90 degrees, and it's marked like this. So here we have a right angled triangle. So the thing to note about this spelling is that the word right and the word angled are hyphenated with this. Okay, so we have a right angled triangle, and a quick way to write the word triangle is that. So we have a right angle triangle, and in this case angle C equals 90 degrees because it's opposite the hypotenuse. Okay, and we also have our famous Pythagoras theorem, which says that in a right angle triangle the sum of the squares of the two legs of the triangle, by the way, an angle has arms and a right angle triangle has legs. Isn't that funny? Okay, so the two legs of the right angle triangle, the squares on them, the size of these squares, add up to the area of the square formed on C. Okay, so a squared plus b squared equals c squared. Look, that's great, we have that done. So to recap, equilateral triangle, did we spell it out nicely? Equilateral, there's the word lateral from quadrilateral. Equilateral, that's a funny I there, isn't it? E-Q-U-I, lateral triangle. Isosceles triangle, where we had two palindromes, and right angled triangle where we have hyphenation and this weird word right. Well, I think it's weird anyway with HT, but I'm getting to terms with it. I'm going to try to stop misspelling things. I'm a teacher, shouldn't be misspelling things. It is stated in the box above that an isosceles triangle is not okay. An investigation. So this is the proof that I showed you about the external angle, and we're into an example. Now, does that example continue on the next page or something? Yeah, but so fine. We're going to do this example now. Example 1, page 169. Okay, as always, we're going to draw it out. Okay, what it is it looks, yeah, it's a trapezium. I didn't say it, but it is. Page missing in this. Sure. Okay, there was a page missing in that. This is page 8. Here's my trapezium. Okay, so just to use the word when we see it, it's a trapezium. So let's reconstruct it. The main thing I notice about this is you've got two line segments that are parallel. Okay, a longer one and a shorter one, but now I'm going to need my compass to reconstruct this because I want to make sure. Now I can come up to any particular point. I can take that point there. Okay. let's go again. Let's form a working line here, and let's now go with this up a fixed amount. Ignore that point there. Okay, we'll go at this point here and mark where I came from, and then I'm going to go out this way at the same amount. Okay, so now we have constructed it so that this length equals this length. Okay, now just to make it look a little bit more like what we're looking at there, bring this out a bit further, but it doesn't say any particular amount. Okay, so let's come down here like so. Okay, so now I've made something quite close to what's in the book, but the difference is I'll be able to interact with this, okay, investigate this far better than I will looking at the book. And that's an advantage you always have in the exam papers. Okay, so give yourself a fighting chance by drawing out the drawings. Okay, and we also have our diagonal drawn in here. Okay, so, and might be observant, so we will say that there, we'll mark that, and be observant is an isosceles triangle here. Okay, so this diagonal internal diagonal angle equals this internal diagonal, and I can indicate that like so. Okay, it tells me and it shows me that this is 29 degrees. Okay, find the angle from M to N to P. From N to N to P. Find this angle. We'll say it again. Find from M to N to P. Okay. I'm going to call it X. So X is the first angle I need. Find from P to M to N. Find from P to M to N. I'll call that Y. Okay, now I have a problem. What does that mean? I have a problem. It means I'm doing an exercise, but it's not an exercise. I'm doing a question I haven't done before. That's problem solving. And what they try to do in the exam is always make it that you're doing a new problem you've never seen before. So we have to go through problem solving steps. Okay, and so I'm going to try and take every bit of maths we've done in the previous sections about geometry and see can we figure out something here. I don't want to look at the solution because that wouldn't be problem solving. Double check that there isn't something I missed. And you see in a parallelogram there's the alternate, hold on, that's what we have. Okay, we do have alternate angles equal to each other. So just by thinking about the situation, I was going to tell you what I couldn't do, and then I discovered I can use it. So it goes like this. These are parallel lines, and so these are alternate angles in the trapezium. Okay, because of our diagonal. So X equals 29. And then in geometry, and you see here the name of the thing is triangles, quadrilaterals, and theorems. So we're going to start talking about theorems and the language around theorems. And one of the things is you want to give a logical explanation for everything you say. Okay, so we're going to be giving a logical explanation for saying that X equals 29. We call it the two-column approach, where you make a statement and you say why it's true, logically why it's true. So the thing is here, just alternate, okay? Because from P to M, line PN is a transversal. Okay, alternate angles. Right, next is we want to find Y. Now here's the cool thing here. I've already marked in the isosceles triangle that this is a dot, the same as this. So it's X. And so basically 2x for those two angles plus y is equal to the internal angles of a triangle, which add up to 180. Okay, but I know what x is, it's 29. So I can do two 29s, we'll try it in our heads, it's 58 I think. So 58 plus y equals 180. So y equals, we'll transpose the term 58, bring it across and change the sign. Okay, and we finish that out with 180 minus 58 equals 122 degrees. Okay, now the difference between me doing this just by the book and figuring it out myself are problem solving. Okay, now and on that as well, I want to say here, sum of internal angles in a triangle equals 180 degrees. Okay, done. Right, we're on to problem solving. So let's get some more paper here. And you know what, I think I'll break up the videos to the theory bit and the exercises bit. So we'll go to our close, which is, as always students, I hope I wasn't coming off the bottom there earlier. As always students, I will see you in the next one.